Hello everyone, welcome formally again. Myself Tamizh, I work as a lead consultant in Nigeria. So this meetup, we have couple of session, like the first session where I'm gonna run through a brief tour of Clojure. I'm going to get self started with the Clojure syntax, and then I'm gonna blow your mind with a short demo of how a typical development in Clojure would look like. And then Kannan will take over and he will be walking you through a hands-on exercise where you will be getting your hands dirty with Clojure. Okay, that is a bird word, but anyhow, that's the term that we use. So yeah, but when you use Clojure, the hands won't be dirty again. All right, so with that being said, let's get started. And so typically the very first thing people will see when they get started in Clojure is the parenthesis. Am I right? Like you would have seen some code in the wild with a lot of parentheses. And trust me, once you get used to it, you won't see parentheses at all. As a matter of fact, you will start to appreciate those parentheses. And those parentheses are there for some good reasons. So I'm going to reveal that good reason in few minutes. All right. So let me start with this code, which is one of my favorite code with respect to programming languages. And this code says, like, the limits of my language means the limits of my world. That's exceptionally true. And if you have seen some movies, especially the movie called Arrival, you would have witnessed this in action. Like, and I don't want to get into that movie because that's a separate talk by itself. But the underlying principle is same. The way you look at your world, is directly proportional to the way you perceive a language. And for example, let me tell you one thing. Okay, see, I'm giving you a problem, and the problem statement is you need to calculate the sum of first 20 add numbers. Okay, I'm repeating it again. I like to calculate a sum of 20 odd numbers, the very first 20 odd numbers. The moment I said, what is running in your mind? A for loop? Am I right? A for loop, and inside a for loop there is a filter with an if condition saying whether it is odd or not, and then we have an accumulator kind of a thing, and then you are doing plus c equal to. So all these things running on your mind, right? So that's one way of thinking about a problem. And if you are into Clojure, you will be thinking like this. And there is no for, there is no accumulator, there is no value mutation. And what you are doing is a simple pipeline operations. Like in the very first expression where I'm iterating through and I'm getting only odd numbers. In the second pipeline expression, I'm taking only the the first 20 numbers. And in the third thing, I'm applying a plus operations over those 20 numbers. Same problem, two different solution. The reason because those two different solutions is coming from two different perspective, and that is being influenced by the language. This is very a trivial example, and think of like in a whole software system where tons of things, there are a lot of moving parts. This particular paradigm will make you to think differently, whether you are going to use Clojure or not. After learning Clojure, when you start working, you will think differently, and hence you will come up with better solutions. At the end of the day, software is all about translating a mental model into some sort of a solution in the form of code. And Clojure, or to be precise, the Lisp and the functional programming paradigm will make you to think differently. Hence, you will end up with a different solution which may not be obvious in the first place. All right. So another core Clojure principle is around this philosophy. Okay. So it says, it is better to have 100 functions operate on one data structures instead of having 10 different functions operate on 10 different structures. So the more you into Clojure, you more you appreciate this philosophy. And Clojure, we have only few handful of data structures, and there are tons of functions which operates on those data structures. So you can easily learn those data structures in few minutes, but in order to get mastery out of the other functions which is out there in Clojure, it will take some time, like anything else. But it's this is the crux of Clojure. And another amazing thing about Clojure is the author of Clojure. Okay, uh, the main reason I started following Clojure is because of this person. Amazing gentleman. Okay, so he has some lovely talks, and the four are are my favorites, to be precise. And on the bottom of the screen there is a GitHub link where you can see there is a fan club for him. Okay, that kind of a person he's. So he has made some awesome talks, and those four talks that I made, mentioned over here: simple made easy, hammock driven development, and the value of values, effective programs. Simply mind blowing talks. So just go through those videos in your own time. Uh, take some time to reflect on those videos. Amazing thought process, and especially it will open up your mind. Okay, and I know I can talk a lot about this, but so since we have a lot of other things to cover, let me stop it here. But just amazing. That's the words I know that is coming on my mind. All right. So let's start with the formality. No, hello world. No, that's how we start with programming, isn't it? So let's get started with the hello world. And in order to do an hello world program, we have two things, or we need two things, to be precise. So one is a way to represent a string, and a function or a method, to print that particular string hello world into the console. And before we get into, you know, to look how it would look in Clojure, let's see in three different languages. I have C, Java, and Scala here. uh, it's called common, right? You have a function called printer followed by a parenthesis, opening parenthesis, and then we have the string representation, and then we are wrapping it by another parenthesis. We have the debatable semicolons, and then in Scala we don't have that one for a good reason anyhow. All right, so that's how we write in a normal programming language. So it's, if we abstract that particular thing down, what we end up with a function and an argument. Clojure's way is different in the sense, instead of putting the parenthesis around the argument, you put the parenthesis around the expression itself. So you start with the parenthesis followed by the function, and then you put the argument. So the same number of parentheses, but the position of those parameters is different. Now your question would be, why this parenthesis in a weird position? I will come to answer that in few minutes. Okay, so this is how it's going to look in Clojure. Like we have a println statement, sorry, function, and it prints the hello world in the console. And Clojure syntax, right? Like the first thing is function, followed by an white space, and we have the argument, and then we have the closing parenthesis. That's it. That's Clojure's syntax for you. Now you know pretty much all the syntax of Clojure. Okay, put a open parenthesis. The first thing in the after the parenthesis is always a function. Put a white space, separate and as a separator, and then put argument and wrap it up with a closing parenthesis. Now let's see how functions with multiple arguments look in different other languages. So what we typically do, after the first argument, we put a comma, and then we put the second argument, and then wrap it with a parenthesis. In Clojure, the same thing. There is no different. Instead of putting the comma and the argument, like the comma is optional here, and it look like this. And multiple argument function will look exactly the same. It will be always function first, and then a number of arguments separated by white spaces. You can put comma if you wish, but the comma will be treated as a white space in Clojure. So that's how a typical expression would look in Clojure. So to get more insight around this syntax, let's have some four more problems before coming to the syntax of Clojure. Okay, I have 4 different requirements here. The first requirement says I would like to add numbers 1, 2, 3, and 4. And the second requirement is converting an integer to a string. The third one is concatenating 2 strings, and the fourth one is the conditional operator that we all aware of. Okay, so let's see how it looks. Like we have 1 plus 2 plus 3, nothing special, just straightforward syntax. And we have converting an integer to a string. Here it is a Java example where string dot value of 1. And then we have concatenating 2 strings where again I'm calling dot concat method over the string. Again, it is in Java. And let's abstract this thing. Okay, if you are coming from CS background, you would have had a subject called the data structures, and there you would have hopefully came across this term infix and prefix notation. The infix notation says like you place the functions or the operator between the operands or arguments in the case of functions. So here 1, 2, 3, 4 are 4 different arguments, and the operator plus is the function that we are operating over these operands. And in prefix notation, we put the operator first and then the operand. Here the function first and then the argument. And in object-oriented programming, where we are invoking a static method here, we put the class name followed by a dot and then the method name followed by the argument. So the one on the top is the a semantic, but one on the bottom is the actual syntax.
Sorry to interrupt. Check if there are any participants waiting to join. I tried joining. Yeah, I think it needs your approval. Also check if there are anyone else waiting.
Yeah, some kind of few.
Yeah, it's me. I tried to connect audio from mobile app.
Okay. Good. Right. Okay. Super. So now I'm getting into another notation where we are invoking a method on an object. Again, the same thing, but the notation we are using is prefix. When it comes to conditional operator, again, I'm not sure whether it is infix or postfix, because it is all, it's more around an infix because we have an argument, then the function, then we have a separator. It's a, typical conditional operator in action, but the notation that we are following is different. The argument is sandwiched, or the function is sandwiched between arguments, and then we have something called a separator in between, which is some special syntax kind of a thing. The same, what we have seen so far would look consistent in Clojure. When I say consistent, there is no infix, a mixture of infix and postfix. It is always prefix. When I say prefix, what I mean here is the expression is always starts with a function followed by a number of arguments. The same plus 1 plus 2 plus 3 plus 4 would look like only once 1 plus followed by 1, 2, 3, 4. And then we have the static method invocation. Again, the first name, the first value is the function name. Here it is a static method, so we are putting the class name slash the static method. Again, that is the one on the bottom is a semantic of the syntax. So the one on the top is the always function followed by an argument. The same applies for invoking an object method also. Okay, Clojure has first class interoperability with Java. So if something that is at least already there in Java, we can easily access them from Clojure using either static method or using this OO in object method invocation. Okay, so what we are invoking here is like I'm invoking the concat function on the hello instance using the dot function. Okay, it's a special form in Clojure. We will get to that later. So, but overall, again, it's the dot is the function, and the arguments are hello. The first argument is the instance in which we need to invoke the method. The second argument is the actual method that we need to invoke. Rest of the arguments are the arguments of the actual method. Here, in this case, the method name is concat. The conditional operator, right? It looks like this in Clojure. Like there is no conditional operator. The if expression in Clojure will help us to implement the conditional operator. It says first argument again is if. Sorry, the first the element is if, followed by true, which is the argument which we need to evaluate whether it is true or not. If it is truthy, the argument 2 will get evaluated. If it is false, then argument 3 will get evaluated. Again, the same prefix notation. And this is how a switch case would look in Clojure. Again, if you look at the case, the function is the first element in the list. Rest of the things like number, 1, 1, 2, 2 into representation, all these things are arguments to this function called the case. So it is always prefix notation. So that's why when I say in the very first thing, right, after writing hello world, now you know the complete syntax of Clojure, that this is what exactly I mean. Now you saw different things, right? Plus, invoking a static method, invoking an object method, there is an if expression, there is a case expression. All these things follows a same syntax. Function followed by arguments wrap around parentheses. That's it. And another important thing when you get started with Clojure is understanding what is a Clojure form is. Okay. So Clojure form is a structure that a Clojure compiler recognizes. By the way, Clojure is a compiled language that compiles to bytecode. So if you and runs on JVM. And there are some dialects. There is something called Clojure CLR, where that Clojure language compiles to .NET, and we have Clojure script which compiles to JavaScript. So, but here the focus is on Clojure, which compiles to bytecode. But irrespective of the underlying VM where it compiles to, the core syntax remains same. It is the list-based syntax, and a form is the common structure that a Clojure compiler recognizes. And there are 3 different types of forms. One is atomic data types, and we call as literals, as in most programming language. An integer represented using similar that decimal notation, and then we have floating point representation, and then boolean true or false. Character is a different in a C based languages we have single parenthesis to represent a character, whereas in Clojure it is backslash followed by the character, and we have double quotes for representing string, and null is represented using nil. Symbol and keyword are something unique in Clojure, in the sense symbol is very similar to the names that we assign to things in other languages. For example, if we say int x equal to 10, x is a variable in another language, where x is something the compiler recognizes as a variable. In Clojure, there is no such concept of variables. Instead, what they do, like they assign a symbol to something. And here x will be assumed as a symbol which is happened to be assigned to 1. And this keyword is again a special things people from Ruby will be aware of, but it's kind of similar, but it is more powerful. So in the sense, like you can play Clojure keyword are extremely useful throughout the Clojure programs, and it can have namespaces as well. So we will talk about that in few minutes again. Basically, a keyword in nutshell, put a colon followed by a symbol name. Okay, it can be anything: :1, foo, customer, ID. It can be anything as long as it is meaningful in your context. Okay, that's literal types. And then we have collections. Again, collections. 1 minute. I guess someone is trying to join. And we have Clojure forms. 1 minute. Oh, yep. So the next thing is collections. Collections in Clojure can have multiple types. One collection type is called arrays. vectors, which is equivalent to arrays in other programming languages. The one it is followed by a square parenthesis, square brackets, and here what you are seeing is a vector with an integer 1 followed by a string 2 followed by another integer 3. So it can have different data types baked in. And then other thing is called the list, which is in parenthesis. I told you earlier, right? Like everything in Clojure wraps around those parentheses. So by default, the Clojure compiler treats the very first element in the parentheses or inside the parentheses as a function. Here I'm having a list of 1, 1.2 and 1.5. And if I didn't put that single quote before that opening parenthesis, it will be treated as a function. So it will treat 1 as a function and invoke with an argument 1.2 and 1.5, which will result in some runtime exception. So in order to avoid that, we need to put single parenthesis, basically a way to represent a list. Again, Clojure, the difference between other languages and Clojure is this particular aspect. The language syntax is created or using the Clojure data structure itself. The property is called homoiconic, where you are using the data structure itself to represent the program. A Clojure program is nothing but a Clojure data structure. That means you can take a Clojure program and transform it, do anything, and then you can give that to compiler and it will still compiles. So that is very powerful concept, and that's why Clojure macros are very powerful. And we will talk about that in some other later sections. But this particular session, we are going to focus only on the fundamentals. Okay, and the third one is Clojure map, where typical hash map, we associate keys and values. Here I'm having 1, 2, 3, where 1, 2, 3 in word as as keywords represent the keys, and the associated values are there. It basically it associates a key to a value. And then we have set, basically non or no duplicate kind of a list, where we have typical set, there won't be any duplicates. So the syntax for that one would be put a hash followed by a curly bracket and a number of items. So that's Clojure collections. And then we have something called expressions. So expressions, we already saw, it's like invoking a function with some argument. And the difference between statements and expressions, when you say statement, for example, in a C-based language, when you say int x equal to 1, what we are actually doing is we are assigning a 1 in some memory space, and we are giving the name x to that memory space. And that particular statement does not return anything. Whereas in Clojure, everything is an expression, and all the expression has to return something. In the case println function, like it's just going to print the hello world, but after printing it, it will return nil. So everything is an expression in Clojure, and all the function invocations are categorized as expression. That is one form of Clojures. One type of Clojure forms. And when it comes to evaluation, right, like when you put some literals, that will evaluate to itself. You can create a new file in Clojure dot, say something called foo.clj, and you put just hello world, it still works because literal will evaluate to itself. And as I mentioned earlier, the expression will always return a value. Here in this case, println and hello Clojure prints and returns null, sorry, nil. And the beautiful thing about these forms, it can be nested. Here there is an expression here that says, we have println function followed by the argument a string followed by an expression again, that in turn uses plus function to add two numbers. And just to give an idea of how the Clojure evaluation model looks, it is going to evaluate from left and right. So when it sees an open parenthesis, it determines that it is an expression. Then it looks for the first argument, function again. So this println function is defined in Clojure core library, and it is a Clojure symbol. So now the Clojure compiler knows this is a function. It moves along. Then we have string, which is an argument 1. I told you like string or literals are evaluated to itself. So that will be written as it is. Then we have an open parenthesis which says it is beginning with a parenthesis. And now we have a symbol called plus, which is again a function defined in core Clojure library. So it moves to navigate to the next argument, which is one integer, which evaluates to itself. And then we have another integer literal, which again evaluates to itself. And then we have a closing parenthesis. Now the Clojure compiler knows now this expression is completed. That means it can be evaluated. So now it evaluates that expression and returns the value, which is 2 in this case. And then we have a closing parenthesis. Now Clojure compiler recognizes that the expression is complete. It evaluates the complete entire operation and it prints 1 plus 1 equal to 2. That is the output of the program. And then we have the nil, which is the return value. So that's the crux of Clojure's syntax. So because of this nature, you can combine, nest any arbitrary expression into any expression, and you can create a program out of it. So that's Clojure evaluation model. There are some deviations to this evaluation approaches. There are something called special forms and macros. Okay, treat it as something kind of a kind of, what can I say, some specialized models which deviates this evaluation scenario that I mentioned about. Okay, so these are all advanced scenarios which we may not need to know to start with, but there are other possibilities that is available in Clojure using which you can change the evaluation model. That kind of power you have. Okay, so we will be talking about that in some advanced session, but this session we are not talking about these things. So to give a summary, like Clojure uses always the prefix notation. If you are coming from a world where you call function with function followed by an open parenthesis, then argument, then it translates to open parenthesis followed by the function name followed by the argument with a close parenthesis. So yeah, and it will be like 1 plus 2 plus 3 in this, which is an infix notation in C-based languages. That translates to 1 plus 2 plus plus as the function in the prefix notation and followed by 1, 2, 3, 4.